everyone, welcome to this learning channel. Today I will be teaching you some strategies in solving mathematics, and for this vlog, I'll be showing you the magic hexagon or the super hexagon, which is a strategic diagram that will help you memorize trigonometric identities the easier way. Now for the disclaimer, this is based on research that this super hexagon was made by the Greeks and by no means mine. So let's get started. This super hexagon includes the acronym QUARTS. I made this by myself, which stands for quotient, opposite, reciprocal, complementary, and shaded clockwise and anti-clockwise. Now I'll be drawing the super hexagon. Oops, this hexagon is not perfect, but it's alright as long as you understand your writing. Okay, now it looks like this. The first thing you have to do is to label each side of the hexagon. You start doing that by this trigonometric function. Tangent, sine over cosine. What you want to do is to place tangent first, here on the first side. So we put tan. Next, we go to the right side. Oh, this is the quotient identity, by the way. Sorry. Okay, so we start here on this side. Then we move to the right. That's where we put sine over here. So we put sine, then we put again on the right side cosine. So that's our basis for doing the quotient identity. Completing the other sides of the hexagon, you just have to put the other identities. Cotangent, just put all the letter C's on the right side for you to easier remember it. And lastly, the secant. Now what you want to do is to proceed in a clockwise direction, similar to the arrows drawn here. So, just like what we did with tangent, sine, and cosine, we get sine. Sine equals cosine and cotangent. So sine equals cosine over tangent. So that's basically how this goes. You just pick an identity, the ones after cosine and cotangent. Next, we choose cosine, cotangent all over cosecant. Next, we do cotangent. Next, cosecant. And lastly, secant. And don't forget to put theta every after the identity. You can also solve the other identities through an anti-clockwise direction. So for example, you choose cosine, you go to the direction of sine, anti-clockwise. Cosine. Remember, all you have to do is just go in a anti-clockwise direction. There, that's the quotient identity. Now for the second identity, which is opposite, we're still going to keep the hexagon, but in a different process. For this one, what we're going to do is we multiply the function opposite to each other, then we get 1 as the value. So we have to put 1 here on the center. And the direction is towards number 1. The direction goes as to the one opposite. So if we choose sine, the opposite of sine is cosecant. So we draw an arrow towards 1 and another arrow towards 1. We multiply sine and cosecant, it becomes sine theta cosecant theta equals 1. The same process goes with cosine and secant. We go in this direction. Same process goes with tangent and cotangent. Even if you interchange the two, the answers are still going to be the same, such as cosecant and sine is still 1. Secant and cosine is still 1, and cotangent and tangent is also equivalent to 1. That's the opposite. Now, let's move on to reciprocal. We're still keeping the superhexagon, but in a different process. Now, the direction we're going to is towards the opposite, but in a one direction manner. So what we do is, we start with sine, go to 1, divide it with the 1 in front of number 1. So it's cosecant. So sine equals 1 all over cosecant. Similar process goes with cosine, goes to 1 and divided it by secant. Similar process with cotangent, 1 and tangent. Now if we interchange this two, for example the earlier cotangent 1 and tangent, we can also start with tangent divided by 1 over cotangent. Oh, my bad, this is supposed to be tangent. There, that's the reciprocal. We're now moving on to the complementary identity. What we do here is, we just have to remember the one beside it. So tangent, cotangent, secant, cosecant. Let's start with sine. Sine theta is equivalent to cosine 90 degrees minus theta. Now we do have to note that theta can be any value. This can be alpha or it can be theta. Next, let's do tangent, then secant later. So tangent is complementary to cotangent. The same process applies if you want to interchange the two. Oops. There, that's it for the complementary angle. Now for this part, we need to shade our hexagon. You can start shading your hexagon at the start from the quotient, opposite, reciprocal, complementary identities. It really doesn't matter if you shade it earlier or you shade it now and it's shaded clockwise, but I usually shade this from the start. But since I'm showing you the process, I want you to understand why we need to shade this hexagon. So you start shading this part. Yes. And not this one. You still have to keep the number 1 in the middle because we're going to need that. Now, let's start with the shaded clockwise and later we'll do the shaded anti-clockwise. Now, this is how the direction goes. We go in a clockwise direction. So from sine, we're going to cosine, and it's going to 1. So let's write that down. Sine squared, we're just going to put a square there, plus cosine squared. So everything in this identity is squared. Now, we're going to do the second part here, clockwise direction. We're just going to add 1 plus cotangent squared theta is equivalent to, remember the direction, it's going to cosecant squared theta. Lastly, tangent 1 secant. There, that's the shaded clockwise. We're now going to do the shaded anti-clockwise. Just a reminder for you guys that in any parts of this identity, in doing the hexagon, in the opposite, quotient or reciprocal, complementary, or the shaded clockwise, anti-clockwise, you're not required to do sine first or tangent first. You can really go anywhere you want. You can go with cotangent first, cosecant first. So that's just a little segue. Now let's start with anti-clockwise. I'm going to start here with 1. Anti-clockwise means you're going against it, so you're going in this direction, to the left. Since in clockwise we're going to the right and it's a plus sign, in anti-clockwise we're going to subtract. Now we're going this direction. I'll start with this one. So 1 minus cosine squared equals to sine squared theta. I'm now going in this direction. Secant squared theta minus cotangent squared theta equals to 1. And lastly, squared theta. Now that's it for the quarks, QORCS. I'll now be teaching you some add-on identities, which is the sum and difference identity. Sine UV Now I want you guys to take a look at this one in cosine. Minus all over the plus sign. This happens when the given formula or the given question to you is a positive sign. You follow the one above it, the first one, which is minus. And if the given formula is a negative sign here, in the given, you have to follow the one below it. So this is the first, the one at the bottom is the second. The same goes with sine. If the given formula here is positive, you follow the positive sign. And if the given is negative, you follow the negative sign. For tangent, if the given is positive, for the numerator, you follow the positive, and for the denominator, you follow the negative. And if the given problem is a negative sign, you follow the one below it, or the one aligned to it, which is negative, is aligned to the bottom part. But in the denominator, you follow the addition sign, because it's the one below it. Okay, I think that sums up all the strategies in solving and memorizing the identities. I'll try to publish here at the end a summary of all the identities for you to study. Should you have more questions or concerns, feel free to comment down in the comment box below. And if you have any advice or tips on my teaching techniques to tailor your needs, feel free to chat that also. And if you find this video helpful, please do subscribe and leave a like. Thank you so much.